The space rock is traveling at half the speed of light. Carl, the astronaut, started timing just as it passed and stopped timing when he saw the dust fly. Knowing that he is 1.3 light seconds from the moon and seeing 3.9 seconds elapse on the stopwatch, Carl deduced that the space rock was traveling at 0.33 times the speed of light. Carl later realized that when the rock struck the moon, it took 1.3 seconds for the light from the impact event to travel back to Earth. After Carl subtracted the light travel time of 1.3 seconds, he revised his estimated velocity of the space rock to be 0.5 times the speed of light. Is the difference between an apparent velocity of 0.33 c versus an actual velocity of 0.5 c an effect of special relativity? The answer is no, this is an optical illusion. What if the space rock came from the direction of the moon toward Carl? When the space rock passed the moon, it took 1.3 seconds for that light to reach Earth, at which point Carl started the stopwatch. Meanwhile, the space rock was already halfway to Carl. 2.6 seconds after the space rock passed the moon, and 1.3 seconds after Carl started his stopwatch, Carl saw it fly by and stopped the watch. Only 1.3 seconds are shown on the stopwatch. From Carl's perspective, the space rock traveled 1.3 light seconds in 1.3 seconds, or the speed of light. Once again, Carl realized that he saw the space rock pass the moon 1.3 seconds after it actually did. So he added 1.3 seconds to the time, getting a total of 2.6 seconds. Traveling 1.3 light seconds in 2.6 seconds yields a velocity of 0.5 c. Are there optical illusions when an object's length is concerned? Let's consider a super long rocket, 1 light second long. We've moved Carl to the nose of the rocket. He will signal when he sees the nose depart. Being 1 light second away, we won't see any motion of the nose, nor will we see Carl signal that the rocket has departed for 1 second after we see the tail depart. Seeing the tail depart while the nose remains stationary gives the illusion that the rocket is shorter than its length at rest. If we were to use measuring rods to compare length in motion versus length at rest, we need a shorter measuring rod to measure in motion. This is starting to look like the special theory of relativity. From the earlier segment, we saw that an object that is receding at half the speed of light, or 0.5 c, will appear to recede at 0.33 c. The tail actually departs and appears to recede at 0.33 c for 1 second. In that 1 second, the tail got 0.33 light seconds closer to the nose. Just as we finally see the nose depart, the rocket appears to be 0.67 times its normal length. The special theory of relativity states that an object traveling at 0.5 c will actually compress to 0.866 times its length at rest. If special relativity actually compresses the rocket, then optical illusions will optically compress it even further. We therefore need a measuring rod that is 0.58 times the length at rest to accurately measure what we see when the rocket travels away at 0.5 c. Einstein himself added to the confusion by mixing optical illusions with reality in his simultaneity explanation. Einstein said, "Events which are simultaneous with respect to the embankment are not simultaneous with respect to the train, and vice versa." The events were the lightning strikes. Say they occurred at t equals 0. The time an observer sees the light emitted from an event is simply the time the event occurred plus the distance from the event at the instant you see it, divided by the speed of light, where t sub o is equal to t sub e plus d sub e over c. Any observer, moving or stationary, that has accurate clocks and distance measuring equipment can determine if the events were simultaneous or not, even if those observers don't see the flashes of light occur simultaneously. Why didn't Einstein warn us about optical illusions? Einstein must have been aware they exist. If his theory does not describe optical illusions, it seems he would not want them muddying the waters of special relativity. People for the next 100+ years would claim relativity is invalid because their thought experiments took optical effects into account, which would result in a different answer than special relativity. Why don't the authors of books like Space-Time Physics or university professors warn us about optical illusions? Let's look at one more optical illusion. Let's see what happens if our long rocket is based on the moon headed for Earth. Since the tail is 1.3 light seconds away, we won't see the tail depart for 1.3 seconds after it actually departs. Since we are only 3/10 of a light second from the nose, we will see it depart after only 3/10 of a second. The launch will be slowed to 1/10 normal speed to more clearly visualize what is happening. This is where optical illusions and special relativity really diverge. The special theory of relativity has no provisions for an object to expand in length. If relativity shrinks a rocket that is moving at 0.5 c to 0.866 times its length at rest, and since optical illusions will make it appear twice as long, the approaching rocket will appear to grow to 1.73 times its length at rest. Clearly, the special theory of relativity does not describe optical illusions. Thanks for watching.